In this video, we are continuing our midterm review and doing some infinite limit practice problems. So the first example I want to look at is from the midterm review. It's question 8, part B. And it's the limit as x approaches negative infinity of negative 3x squared plus x minus 6 all over x minus 2. So as with all these practice problems, I want to start by giving you a chance to try it. Pause the video for about 2 minutes to try this question. 4, 3, 2, 1, pause the video. Pause it for about 2 minutes to try this. Alright, so hopefully you've done that. Hopefully pause the video for 2 minutes to try this. So there are two methods that we talked about in class for handling these infinite limits of rational functions when you have a polynomial divided by a polynomial. So method 1 is factoring the highest power. So factoring the highest power. Okay, so that was method 1. So let's do it that way first. So let's do it by factoring out the highest power. So we have the limit as x approaches negative infinity. And let me just preface this by saying, I could definitely on an exam ask you an infinite limit question and say, do this without the shortcut. Because it's important to understand how do we do it without the shortcut. Because method 1 actually motivates where the shortcut comes from. And I don't want us to forget that. Okay, and the heart of understanding the shortcut is really understanding why method 1 works. So factoring out the highest power. That means factor out the highest power from the numerator and factor out the highest power from the denominator. So from the numerator, it's x squared. And factoring it out, I'm left with negative 3 plus 1 over x minus 6 over x squared. From the denominator, the highest power of x is x. And if we factor that out, we're left with 1 minus 2 over x. Okay, so we factored out our highest powers from the numerator and the denominator. I can simplify a little bit, like I can cancel an x from the top and the bottom and be left with a 1 down here and an x up there. And now that we've canceled a little bit, let's try plugging in. If I plug in negative infinity, I get negative infinity plugged in for this x out in front times negative 3 plus 1 over negative infinity minus 6 over negative infinity squared. And on the denominator, we will have 1 minus 2 over negative infinity. All right, so continuing to simplify, we have negative infinity times negative 3, and then when you have something like a finite number divided by something huge, like a negative infinity, it's going to be really, really small. So it's going to approach 0. So I'll write plus 0, and the next fraction, again, will be 0, so I'll get minus 0. And on the denominator, we have 1 minus 2 over negative infinity is going to be 0 for the same reason. Okay, so on the top, I have negative infinity times negative 3, which is going to be positive infinity. And positive infinity divided by 1 is going to be positive infinity. And that is our answer. This is positive infinity. Okay, so that was without the shortcut. Method 2 is, well, use the shortcut. Method 2 is shortcuts. Okay, so the shortcut says we keep only the dominating terms. So in this case, the dominating terms are the highest power terms. Those are the ones that dominate the growth. So if we do that, we get the limit as x approaches negative infinity. So on the top, we'd only keep negative 3x squared. On the bottom, we'd only keep x. So we're only keeping the highest power terms because those are the ones that dominate. They grow the fastest as x goes to infinity or as x goes to negative infinity. So we can simplify a little bit. This is the limit as x approaches negative infinity. And I could divide the top and the bottom by x and be left with negative 3x. So now if we plug in, we get negative 3 times negative infinity. Negative 3 times negative infinity, that is positive infinity. And that's the same thing that we got with method 1. So it's good that we're getting the same answer. And like I mentioned before we got into this example, I want you to know, so you should know, both methods. I do want you to know both methods. I could certainly ask you to do a problem like this, but specify which method I want you to use. I want you to be comfortable with both. Okay, so let's do another example. So this one is one of my own. It's not from the midterm practice problems. Let's do the limit as x approaches negative infinity, but of this exponential type function. So pause the video this time for 3 minutes to try this example. 4, 3, 2, 1, pause the video. Pause the video for 3 minutes to try this example. All right, so hopefully you've done that. Hopefully you paused it for about 3 minutes to try this. So the first thing that I'd want to do is maybe plug in to see what's going on. And if I plug in, I get e to the positive infinity, because I get a double negative. And then I get plus e to the, again, the double negative will become a positive, and I get e to the 2 times infinity. On the denominator, I'll get e to the negative infinity first, minus 5 times e to the, and then negative 3 times negative infinity will become positive, and it'll be 3 times infinity. Okay, so, well, on the top I have e to the infinity, and I have e to the 2 times infinity. Both of those are infinitely big. So the numerator is infinity, because it's infinity plus infinity. On the denominator, e to the negative infinity, if we think about the graph of e to the x, so this is brief review. We've seen this graph now several times in the lecture videos, the graph of e to the x. But if we look at the graph of e to the x, if we look at what's happening to this, as x gets really negative. As x goes to negative infinity, that's this part of the graph. And the y values there are approaching 0. So that's what e to the negative infinity is. It's 0. So e to the negative infinity is 0. And then after that, we have minus 5 times an infinitely large thing. So that's minus infinity. Okay, so overall we have infinity divided by negative infinity, and that's an indeterminate form. And that's what makes us need to simplify this. Okay, and it's an infinite limit because x is approaching negative infinity here. So can we do something similar to what we did in the last example with our rational functions? And the answer is yes. We just have to identify which terms sort of dominate the growth. So on the denominator, it's easy to see. This term dominated the growth because the other term went to 0. So the other term got really small, but this one that I boxed got really big. On the numerator, e to the 2 times infinity is definitely larger than e to the infinity. So e to the 2 times infinity is the one that dominates the growth. So the ones that I boxed, they dominate the growth. So just like we did in the example above, we are going to factor out those terms that dominate the growth. So I want to do this without the shortcut. So the term that dominated the growth in the original function was this one on the numerator, this one on the denominator. Okay, so if we factor out e to the negative 2x from the numerator, what we will be left with from the first term is we'll have e to the, and it's the power that was there originally, minus x, minus the one that we just took out. And we just took out a negative 2x. And then what's left over from the e to the negative 2x? Well, there would be a plus 1 left over. On the denominator, I'm going to factor out e to the negative 3x, because that's the term that dominates. When we do that, from the first term, we'll have e to the power that was there originally, which is x, minus the one that we just took out. So the one that we just took out is negative 3x. All right, and then from the second term, what's left over is minus 5. Okay, so now if we simplify this, if we simplify this, we got the limit as x approaches negative infinity. And then with the e to the negative 3x and the e to the negative 2x in front, if I were to take this e to the negative 3x and I were to bring it up to the numerator, in the numerator it becomes the e to the 3x. And if you multiply e to the 3x times e to the negative 2x, we end up getting e to the x. Okay, so I'm going to erase that e to the 3x. It was just a placeholder. Okay, so we have e to the 3x there, and then times, we have e to the negative x plus 2x is x. And then we have the plus 1 after that. And then all over, now the e to the negative 3x is gone because I moved that up to the numerator. And what's left over is we have e to the, we're going to have 4x and minus 5. All right, so I'm moving that up to the top of the page to give myself more room. At this point, we've simplified it a bunch. Let's try to plug in. That gives us e to the negative infinity times e to the negative infinity plus 1 over e to the 4 times negative infinity minus 5. Well, e to the negative infinity, we've seen that that's 0. So we get 0 and then times 0 plus 1. On the denominator, 4 times negative infinity is a negative infinity. So this is e to the negative infinity in the denominator here, the first term at least, which is 0. And then we still have the minus 5. So overall in the numerator, we get 0 times 1, which is 0. The denominator is negative 5. And 0 divided by negative 5 is 0. And that is our answer right there. So in terms of our goals, we have now done a bunch of limit practice problems. We did infinite limits in this video, and in the previous video we did finite limits as x approached some finite number. So in the next review video, we will do some definition of the derivative practice problems.